students. Hello from Mrs. Thompson. I am so glad you are watching today and interacting with me. We're in section 4.8. We're getting ready to do example 3. And if you have not done example 2, you need to stop this video right now and do example 2 because we learned a certain keying sequence for finding the line of best fit. And you need to know how to do that first before you do this example. Okay? Now, as you may recall, in example 2, you noticed on your calculator that the last value was R, okay? And here it is, right here, I'm going to underline that. And that's something we call a correlation coefficient. That tells us some very, very important information about the correlation, okay? Now, I told you in the last video that I would show you how to get it on your calculator if you don't see R squared and R. If for some reason your calculator is only showing you len reg y equals ax plus b, giving you a, giving you b, and then it stops and there's nothing else under there, there's no R squared and there's no R, I told you that I would show you how to do that, and I am true to my promise. Okay, I'm going to switch over to the camera. And what I want you guys to do, we're going to please turn on your calculator, get those screens up, and in order to check and see if, and even if you're not sure, you can always go back to the stat button, calculate, go down to len reg, which is linear regression, hit enter, and then I got to calculate. My calculator does a little bit differently. And then all the data from that last example is still in there, and my calculator is showing the R squared and the R. But what if yours isn't? Let me show you how to handle that. All right, let's quit that screen, so hit second mode. And then what I want you to do is hit second 0. We are going in the catalog, and we are looking, I want you to hold the down arrow and just keep holding it. We're looking for the word diagnostic on. So we're trying to get to the D's. So it's going to keep going down. I'm just holding my down button, and we're just waiting for the calculator to get us to the D's, and then we're going to get to diagnostic on. Okay, so there it is. My arrow is immediately to the left of it, and you're going to hit enter and hit enter again. And now, if you didn't see the R squared and the R before, you should see it now. So let's test this theory, and hopefully it's there. Go stat, calc, arrow down to 4, or press 4, enter. Goes with my calculator, arrow down to calculate and hit enter. And you should now see R squared and R. Now you will see R squared and R if there was data in there to begin with. I had data from example 2 in there, so I just wanted to show you that it will appear from now on. Okay, so if you don't have R squared or R, hit second 0 and scroll down to diagnostic on, hit enter twice, and it should load that for you. Okay, so let me clear out of here, and I'm going to go back to the other screen now. There we go. And I want to talk to you about correlation coefficient. Correlation is exactly what we've talked about before in previous chapters. If in your scatter plot, if your points are kind of clustered and leaning towards the right, that indicates a positive correlation. And what that shows up as is that correlation coefficient, your R is going to show up as a number, a decimal, fairly close to 1. Okay, so in the 0.8, 0.9 range. If there's no correlation at all, remember that in our scatter plot, it wasn't leaning right, it wasn't leaning left, then it shows up on your calculator as a decimal around 0. So it could be like positive 0.1, positive 0.2, or negative 0.1, negative 0.2. Those are decimals that are around that 0, and that indicates no correlation. And then we did talk about points that are clustered, but they're kind of leaning left. And so that data set, you're going to have a decimal real close to -1. So it should show up as -0.9, -0.8. something like that, that would indicate that negative slope, a very strongly negative correlation, okay? So that's what a correlation coefficient is we can tell how strong or how weak that correlation is. So here's a helpful hint. I actually took this right out of your book. R values close to 1 or -1 indicate a very strong correlation. The closer R is to 0, the weaker the correlation is. So that's a great way to look at that. So that R value is important because it tells us the correlation. Okay? Now, we're going to do example 3, correlation coefficient, and the table shows a relationship between a city's population, and that population is in thousands. So like Albuquerque, New Mexico, that doesn't mean there are 505 people. That's 505,000 people. We just don't put the extra zeros there. We do denote it up here. That's important. You need to show that we mean these numbers to be in thousands. We're not going to write the 505,000, however. And then, of course, the average time the city's citizens spend commuting to work each day. So you look at those numbers, that's in minutes, okay? So our first objective, we need to find an equation for a line to best fit, and then we're going to decide how well does the line represent the data. Now, whenever you're asked a question like this, how well does the line represent the data, they are asking you to assess the correlation coefficient, which is R. That's what they're asking you to do. Is it strongly positive, strongly negative, that kind of thing, okay? Now, on the next page, I created a chart. I only did the positive side of the chart. I did not do the negative side of the chart, but it would be flipped, just negative on the other side. So remember what I told you, numbers clustered around 0 means little to no correlation at all, okay? And then numbers that are around the 0.3 to 0.4, it's weakly positive. It's not real strong at all, okay? And then as we get to the halfway point, 0.5 to 0.7, it's moderately positive. And then we get up here to 0.8, 0.9, and as close to 1 as we get, that is strongly positive. And that's how we want to look at it. So we want to categorize it as either being little to no correlation, weakly positive or weakly negative, moderately positive or moderately negative, strongly positive or strongly negative. That's what we want to do. We just want to be able to do that. And I think in your book, they use pretty much nothing real technical. I think they say they summarize it that it correlates very well or not at all. I think they're even more simplistic than even what I have written here. So let me flip back to this page, and actually what I'm going to do is I'm going to flip to the camera now, and we are going to input our data. So turn your calculator on, hit the stat button, and hit enter. Oh, we have data from yesterday or from whenever we did this video, so we're going to clear it out. So highlight L1, then hit clear, enter, and then highlight L2, clear, enter, and that takes away all the information. All right, in that first column, what I need you to do under L1 is I need you to put in the population. So let's get started. 505, 486, 710, 630, 2833, 146, 2144, 553. Whoop, I didn't write that right, so we'll just overwrite it. 8496 and 223. Guys, it doesn't hurt to double check those numbers. Even if you're one digit off, it will throw off your whole equation, and you don't want to do that. You want to be accurate and right on top of it. So if you're on a multiplication test, a multiple choice test, what you want to do is if for some reason your equation doesn't match up with anything on your test, double check your numbers. You may have punched something in wrong. All right, let's go to the L2. We're going to do our average commute in minutes. So there's 21.5, 31.1, 23.2, 25.1, 30.6, 17.9, 27.7, 25.2, 34.0, and 24.2. And it doesn't hurt to just double check those numbers for accuracy. All right, it's looking good. I'm just doing a quick double check and assessing, are my decimals in the right place? Did I hit all the digits, etc. and so forth. All right, let's calculate. Stat, calc, 4, and then we want to go to calculate, enter, and there's our equation, okay? So it's really important that you are looking and just writing down in that space. I'll flip back to the other page in just a second. Let's round that to 2 decimal places. I'm going to go out quite a few, I think, because of the zeros, just for accuracy. And B, I'm just going to go ahead and round B to 23.78. And R is about 0.711. Okay, so let me flip back to the other page. We've done our work that we needed to do on the calculator, and now we're ready to find the equation, write that equation, and we've got y equals 0.001355x plus 23.78, okay? Lucky you don't have to interpret the slope or the intercept, so I'm so happy for you. There's your equation. Now they do want us to assess the R. They're asking us, well, how well, there's that word well, how well does the line represent the data? So this is what we found out is, there's the R, there's the correlation coefficient, it's around 0.7, and they're asking us how well. You can use my terminology like I showed you on the other page, and you could say it's moderately to strongly positive, so you could use my terminology. I'm not sure that you'll see that on a test, but you might. And the book actually, since they're asking how well, you could say very well. This correlation coefficient indicates that this line represents the data very well. The closer to 1 that the number is, that your correlation coefficient is, the stronger the correlation is. So this line does represent the data very well, okay? So very well. So I wanted to give you a couple ways to assess that R. We know it's moderately to strongly, and I forgot to put positive. It is a positive number. It's close to +1. And in fact, if I graph this data, it should be clustered leaning right. So that's definitely true. Okay, so that's a little lesson on correlation coefficient. If you have any questions, rewind this video and let me talk you through the correlation coefficient one more time. If you're having calculator issues and you can't figure out how to get your R to show up, come see me first thing tomorrow so I can help you with that and so that you'll be ready for class. Hopefully you had your calculator with you. It does help when having a calculator when we're doing this stuff. All right, bring your questions to class tomorrow. Thank you for your attention.